In this video, we're going to look at the activity series involved in our oxidation reduction reactions. A quick review of our oxidation reduction reactions. When we do a redox reaction, that's when we're either gaining or losing electrons. So remember, X can be oxidized by Y, X loses electrons, Y is reduced by X, Y gains electrons. Now, how do we know which one actually gains or loses electrons? For that, we look at the activity series. In the activity series, we have listed metals in order of how reactive they are, starting with potassium at the top is our most reactive, down to sodium, magnesium, going down to cadmium, cobalt to lead, hydrogen's in there. And then finally, we have our least reactive metals. The activity series is ranked from the most reactive at the top to the least reactive at the bottom. A more reactive metal or a more active metal will displace a less active one. So that means higher on the chart, that metal wants to be an ion and will give up its electrons easier than metals lower on the chart. An example here, if we have copper reacting with silver nitrate, gives you copper nitrate plus silver. Now, if we look at the reactivity series, we can see we have copper right here and silver right below it. So when we're trying to compare these two metals, since copper is higher on the activity series, it's more likely to give up its electrons. It's more likely to be oxidized. So we can say copper is going to be oxidized by silver. And so you can see in our reaction, copper ends up as an ion in the product, and silver is a neutral atom. So silver gained electrons. It went from a +1 state to a 0 state. Copper went from a 0 to a +2. So we can do this with any metal on the periodic table. Anything that's higher on the periodic table will become an ion on the product. And so if we look at the reverse reaction, and let's say we have copper nitrate reacting with silver metal to give us silver nitrate plus copper. Note, since copper is the neutral atom here and silver is the ion, but silver is lower on the periodic table. So that means silver will not do this reaction. We will not get this reaction to happen. We only get the top reaction. So this is how we can use the activity series to determine if our reaction will actually occur. And so let's look at a couple pictures to see these two types of reactions that we showed. We can see here we have copper metal placed in a silver solution. Here we have a silver metal placed in a copper solution. And then we let it sit, we let it react. Afterwards, we can see that on our copper metal, we're actually getting some silver solid to form. So you can see there's a little bit of silver solid that's covering our metal, our copper now. It's not nearly as shiny as the copper we started with. However, if we look at our silver here in the copper solution, we can see nothing happened to it. It looks the exact same as the starting one. So this is what happens with our activity series. We can figure out which one of these mixtures would actually react. And you can see it's only when you have the copper metal, which is more reactive than silver, that we get this reaction to occur. So once we know we have an oxidation reduction reaction, we then look at the activity series to see which one will react, to see which metal is more reactive. The more reactive metal is the one that's going to be the ion in the product. The less reactive metal should be the solid in the product. If you don't have that sort of configuration, you're not going to get an oxidation reduction reaction to occur. And we can always check to make sure we've done a proper oxidation reduction reaction by looking at the oxidation numbers. So remember, anything higher on the periodic table, these are the ones that are going to be the ion in the product versus anything lower. So it doesn't matter which two metals we pick, as long as you can find them on the activity series chart, you can figure out if it's going to react or not.